you are asked to find out the marginal effect or the elasticity coefficient. By the way, in my notes, I did manage to fit all of these 7 models into one page very neatly, but on this whiteboard, I could not manage to do so. So if you want a copy of this, you can let me know in the comment section and I will be happy to share it with you. Hi guys, in this video I'm going to talk about one common question which students usually fail to attempt because they have not practiced it. So in this short video I'm going to quickly go through the 7 main models that can possibly be given in an exam situation so that you can practice those and hopefully you will not be one of those students who fail to attempt this kind of a question. So let's say you're given a model and you are asked to find the marginal effect. How would you do that? Or for example, you are asked to find out the elasticity coefficient. So that's pretty straightforward. In order to obtain the marginal effect for any given model, you simply have to differentiate it. Therefore, to get ME, that is the marginal effect, you simply obtain dy by dx and that is going to give you the marginal effect for that model. And similarly, obtaining the elasticity coefficient, that is EC, is also very straightforward. You simply have to multiply ME by x over y. In other words, the answer that you get in the first step, which is to obtain the marginal effect, that is the first step, okay? So when you get dy by dx, the answer that you get at this step is simply going to be multiplied by x over y and that is going to give you the elasticity coefficient. So there are just 2 steps that you need to apply. Number 1, obtain the marginal effect, and how do you do that? By differentiating the model just once. That is, dy by dx is going to give you ME, that's step number 1. And step number 2 is to simply multiply that answer with x over y and that is going to give you the elasticity coefficient. So just 2 steps and you're good to go. However, keep in mind that you have to be familiar with the log rules and also the basic rules of differentiation in order to be able to obtain the marginal effect, because if you don't know the rules of differentiation, you will not be able to actually differentiate the given model. Okay, so let's say that you are asked to find out the marginal effect or the elasticity coefficient of this given model. So the first step, as I've already told you, is to simply differentiate it. So if you differentiate it, dy by dx is going to equal to beta 2. So in this situation, when we multiply beta 2 by x over y, we get the elasticity coefficient, which is beta 2 into x over y. So that gives us the answer. And in this situation, obviously, we can see that this is a simple Lin-Lin model. Now coming to the next one, we know that we simply have to differentiate the model. So we get beta 2 into 1 over x if we differentiate this, and then this gives us the marginal effect, right? Now we have to multiply this answer. By the way, I have skipped the dy over dx because of lack of space. So dy by dx in this situation equals to beta 2 into 1 over x, right? Now when we multiply this term by x over y, this is what we get. Why? Because the x cancels out, right? So beta 2 1 over x into x over y is simply equal to beta 2 over y. That gives us the elasticity coefficient. And we know that this is a Lin-Log model. Okay, so coming to the third one, at a glance you can see that this involves a reciprocal term. So this is a reciprocal model. Now be careful, because when you differentiate this, you get minus beta 2 over x squared. So it's a negative term, okay? So dy by dx in this situation is equal to minus beta 2 over x squared. And when we multiply this by x over y to get the elasticity coefficient, we get minus beta 2 over xy, because once again one of the x's is going to cancel out, right? Because we have x squared in the denominator and we also have 1x in the numerator, so obviously we're going to be left with only 1x in the denominator, which is why this is our final answer. Now coming to the fourth one, we have yt is equal to beta 1 plus beta 2x plus beta 3x squared plus u. So we can see at a glance that this model is a polynomial model because it involves x raised to the power 2. Now when we differentiate this, we simply get beta 2 plus 2 times beta 3x, that is dy by dx in this situation is equal to beta 2 plus 2 times beta 3x. And when we multiply this term by x over y, we get beta 2 plus 2 beta 3x. Now coming to the fifth one, we have yt is equal to beta 1 plus beta 2x plus beta 3xz plus ut. Now once again we can see at a glance that this involves an interaction term, which is why the name is interaction for this particular model. Now when we differentiate it, we simply get beta 2 plus beta 3z, and the elasticity coefficient in this case is once again similar to the previous one, x over y into beta 2 plus beta 3 z. Okay, moving on to the sixth one, things can get a little bit complicated, but if we follow the step-by-step approach to first obtain the marginal effect and then simply multiply it by x over y to get the elasticity coefficient, things are going to be really easy. So since obtaining the marginal effect involves some working, I have done it separately over here in this space. So ME is computed as follows. This is how basically we get beta 2 into y, because you have to note that this model involves a log term, right? We simply remember the rules of differentiation which are applied when we have a log term, and this is why I have 1 over y into dy over dx, which gives us simply beta 2 into y. So in this situation, dy by dx is equal to beta 2 into y, and this is the working for that. And in case you don't know how I have done this, then there are lots of videos already available on YouTube which explain the basic rules of differentiation, and you can watch those in order to understand how we get beta 2 into y for this particular case. Now, when we multiply beta 2 into y, that is the marginal effect, with x over y, because we have to do that in order to get the elasticity coefficient, right? So you notice once again that the y cancels out because we have y in the numerator and y in the denominator. So we are left only with beta 2 into x. That is why the elasticity coefficient for this particular model is simply beta 2 times x. And of course, the name of this model is the Log-Lin model, because we could already see that the dependent variable is in log form. And guys, finally the seventh one is ln yt is equal to beta 1 plus beta 2 ln xt plus ut. Now, once again, we notice at a glance that we have log on both sides of the equation, that is the dependent variable as well as the independent variable are in log forms. So this is why the name of the model is the log-log model, or as you already know, it's also known as the constant elasticity model. And as we will see, the elasticity coefficient is actually a constant. So first of all, to obtain ME, oh by the way, ME is going to be equal to beta 2 times y over x. So once again, applying the basic rules of differentiation, this is the working of obtaining the marginal effect. So in this situation, dy by dx is equal to beta 2 times y over x. So once we have the marginal effect, we simply multiply it by x over y as usual, and this gives us the elasticity coefficient, which is equal to beta 2. Like I already said, this is why the log-log model is also known as the constant elasticity model or the double log model. Whereas you can notice we have x in the numerator and we have x in the denominator, and same goes for y. So all of these terms simply cancel out, which is why we are left just with beta 2. So we have gone through all of the 7 models and the derivation of the ME, that is the marginal effect, as well as how we obtain the elasticity coefficient for each of these 7 models. So in the exam, you can be asked to find the marginal effect or the elasticity coefficient for any of these models. So you have to remember how to differentiate each of the given models in order to obtain the marginal effect, and then of course obtaining the elasticity coefficient is just a matter of multiplying it by x over y, and that is pretty straightforward. But if you don't know how to apply the rules of differentiation, you must practice in order to obtain the marginal effect for any given model.